Okay, so let's think about the sine of 120 degrees.
Okay, well,
Okay.
you take the reference angle.
Okay, so first things first, I want to figure out where 120 degrees is.
60 degrees away from 180, which is where you put your reference angle.
Left and up a little bit.
Okay, so you could be like, okay, so it's 90 and then 30 more.
Yes.
Or you could be like, it's 180 and then back 60.
Yeah.
I don't care which way you do that.
Do it the second way.
So I would think about that as being this way or this way.
Yeah.
What else?
But do the 60 degrees. You need to know 60 degrees.
Yeah, and you really want to know 60 degrees, right? So put your reference triangle in here. What's your reference triangle look like?
30, 60, 90.
60, 90.
So that's a
Yeah, and you do opposite of the right hypotenuse.
this one. So 1, 2, square root of 3.
Yeah.
Whole means?
You square root of 3 or 2.
Okay, so the sine is the
Opposite over the hypotenuse.
Square root of
opposite
3
over the hypotenuse. So this should be square root of 3.
Negative square root of 3 over 2, because you're
Over
on
2?
Y land.
No, because in the second quadrant, sine is positive.
No, because in the second quadrant, the sine is positive.
Yeah.
You guys with that?
Sine.
Right, and we're going up. So maybe that would help.
Because if it was cosine, that would be
If it was cosine, it'd be negative.
Yeah.
So, kick of this is, if I pretended for a second that I didn't know what angle I was talking about. You know, I just wrote, oh, this paper got smudged, right? You know, I spill my, like, I'm doing some work, I spill my coffee on my paper, and this gets a little smudgedy, and all this crap gets smudgedy. But I still know that this is square root of 3 over 2,
I
right?
know what it is. Yeah.
How would I get a hold of the angle again?
Just draw a triangle. Because you know what sine is opposite over hypotenuse, which is
sine 60 degrees.
Okay, so we could notice that these are standard angles, right? And then we could draw a triangle. Or we could get out our calculator. So pull out your calculator quick.
And do the inverse sine.
Type this in and then hit sine inverse.
You want it in radians or?
Don't care.
sine inverse is square root of 3 over 2.
I would prefer if you all move to thinking in radians,
Fair enough.
unless you're going to be a forestry person, come on. In which case you should think in degrees.
In radians, it's 1.0471975551.
1.05 was I think
Yeah.
the rounding I heard. And in degrees, should be 60 degrees, right?
Yep, 60.
But it was supposed to be 120 degrees.
But we don't know that because we spilled our coffee on it.
You guys see that?
Because it only goes back to the reference angle.
Yeah, so this goes back to the, well, it's not quite a reference angle because it might give you something in the right half of the unit circle.
Okay.
You guys see that?
Yeah.
It's a little better than a reference angle because it still gives me the positive or negative,
Okay.
but it doesn't do the reflections.
Okay.
You guys see that?
It doesn't know. which
So
is which.
the best it's going to get you is
In those.
up or down.
Okay.
It's not going to get you left or right.
Okay, that makes sense.
And the cosine inverse will get you left or right, but not up or down.
Yep. This makes a lot of sense.
You guys cool with that? So you have to be a little careful with these, right? So this could be 60 degrees, or it could also be 120 degrees.
Can you do 35 and 7.8?
Sure.
I think you can touch it.
You guys cool with this stuff?
Yeah.
Okay. So basically the moral of the story is just, if you're using the sine inverse or the cosine inverse or the tangent inverse, be a little careful. They're not actually inverse functions.
Okay.
You have to like draw a picture and think about it. It helps if you know where the answer is going to live.
Yeah.
So that sine will live on the right-hand side, cosine will live on the top, and tangent will live on the
Top, that'd be right.
tangent lives on the right.